For centuries, humanity has looked to the sky for answers, building theories, writing equations, and imagining our place in music, a grand cosmic puzzle. But all of that, our physics, our cosmology, music, our understanding of space and time, has just been shaken to its core. Because what the James Webb Space Telescope has just seen wasn't supposed to exist. Galaxies too old, planets too large, structures, music, too perfect, and a signal steady, rhythmic, and unnatural that doesn't fit into any known, music, astrophysical model. This isn't just another discovery. This is a collision between what we believed and what actually is. The James Webb Music Telescope may have just delivered the most profound warning and invitation in human history. And if it's real, then everything we thought we knew about the universe, music, is wrong. In a series of deep-field observations, the James Webb Space Telescope captured music, some of the most detailed images of the universe ever seen. But beauty wasn't the only thing hidden in those pictures. Music, in the galaxy cluster Abell 2744, researchers found unusual alignments and structures that appeared in the data. In NGC 1365, music, a spiral galaxy, unusual motion patterns suggested gravitational behavior that challenged existing models. But it didn't stop there. Similar anomalies began appearing across music, multiple images. The farther James Webb looked, the stranger the universe became. Patterns repeating, music, across billions of light years. Structures showing geometric precision in a cosmos that was supposed to be random. Scientists tried, music, to call it coincidence. But there were too many, too frequent, too perfect. And slowly, the whispers began. Maybe we're not seeing randomness at all, but a form of music, order we simply don't yet understand. Among the many targets of the James Webb Telescope was an exoplanet named HIP 654226b, music, located hundreds of light years away. And what it, music, revealed left astronomers speechless. This planet is several times the mass of Jupiter, orbits its music star at a distance far beyond Neptune's orbit, and exists around a star barely 15 million years old. By all known theories of planetary formation, this planet shouldn't, music, exist. There's no visible protoplanetary disk, no leftover material, and no obvious gravitational explanation for how such a music massive world could form so far out, so quickly, and remain stable. Some researchers have begun to speculate. What if this planet isn't a product of its current system at all? What if it's a remnant of a previous cycle? A relic from music, a star system that came before, somehow transplanted, reused, or deliberately placed? For now, there are no answers. Just a planet glowing at over 1,000 degrees, suspended in a system that shouldn't have had time to build it. In one of the most surreal discoveries yet, James Webb imaged what's known as an Einstein ring, a gravitational lens, music, caused by a massive foreground galaxy bending the light of one directly behind it. But this ring, located, music, around galaxy J418, isn't just any lens. It's nearly perfect. A full, uninterrupted, music circle of light with such mathematical symmetry that even experienced astrophysicists were left stunned. For such an image and a music to exist, the alignment between the two galaxies must be extraordinarily precise, down to tiny fractions of a degree across billions, music, of light years. That's not just rare. It's statistically improbable on a cosmic scale. And while gravitational lensing is a known phenomenon, the degree of perfection here is raising far more questions than answers. Could this be a hint of some deeper symmetry embedded in spacetime itself? A sign that the universe isn't music, as chaotic as we've assumed, but instead governed by a geometry we've barely begun to perceive? But no discovery has, music, rocked the scientific world like this. The James Webb Space Telescope has found massive, mature galaxies forming remarkably early in cosmic history, just hundreds of millions of years after the Big Bang. That may sound far away, but in cosmic terms, that's extraordinary. According to some current models, galaxies shouldn't have had enough time to grow to these sizes, organize themselves into complex structures, or produce the brightness Webb has recorded. Some early galaxies appear surprisingly massive and developed, when the universe should have still been a chaotic sea of gas. This has left cosmologists, music, scrambling. Because if these galaxies truly are as mature as the music data suggests, then our understanding of how galaxies formed in the early universe needs serious revision. The Big Bang, music, long treated as the foundation of modern cosmology, remain strongly supported by multiple independent observations, but these early galaxies have forced scientists to reconsider parts of the standard picture. And as some researchers are music, now saying openly, we may be looking at a universe whose earliest chapters were far more complicated than we once imagined. In a region far from any major galaxy, Webb detected music, something completely unexpected. A gravitational lensing effect in a patch of space, music, where nothing obvious is visible. No stars, no galaxies, no black holes. Yet light from more music, distant galaxies bends, curves, and distorts as if something massive is hiding there. Astronomers have tentatively, attributed this to dark matter, a form of mass we can't see directly but which exerts gravitational force. But the precision and intensity of this lensing effect can challenge even that interpretation because the distortion appears unusually strong and localized. It behaves not simply like a diffused cloud of dark matter, but potentially like a concentrated structure with a defined mass distribution. Could it be a cluster of dark matter condensed into a shape we don't yet understand? Or is this gravitational echo the remnant of something older, something left behind? Some physicists are now quietly floating ideas far more radical,